Okay, so, yep. Since this is a rhombus, looking for x, this diagonal bisects this angle. And so what do we know about these two angles right here? They've got to be congruent to each other. This angle and this angle are going to be congruent. So we're just going to set them equal, solve for x. So we have 3x plus 12 equal to 5x minus 2. And then just solve for x, so minus 3x. So we get 12 equals 2x minus 2. Add 2. 14 equals 2x divided by 2. And so x equals 7. Which if x is 7, how big is each one of those angles? They'd both be 33 degrees each. Which is bigger than what they actually are. But anyways, okay. The next one says find y. And so we see the y right here. And this is pointing to that angle right there. So in a rhombus, what happens where these two diagonals meet? Okay, they're perpendicular. Okay, they make a 90-degree angle. So we're going to set 8y minus 6 equal to 90. All right, so we're going to add 6. And so y equals 12. Alrighty? Okay, this next one says QRST is a square, so that's important. It says find n if the measure of angle TQR is that. So TQR is this angle right here. Now since this is a square, how big is that angle? 90 degrees, because a square is a what? Because it's a rectangle, right? A square is a rectangle, so you know the angles are 90 degrees. So we're just going to set 8n plus 8 equal to 90. Solve for n. Minus 8. 8n equals 82 divided by 8. Okay, we are going to get a decimal, so 10.25. Okay, so on your quiz in a second, if you get a decimal like this, round to the nearest hundredth like that. Give me 2 places after the decimal. Okay, on the back, there is a back to this and there's a back on the quiz, so make sure you pay attention for that. It says, which statement is true whether this is a square or a rhombus? Now, first of all, again, what does this little symbol right here mean? It means perpendicular, which means what? It means that the two lines make a 90 degree, and then obviously this right here means parallel. Okay, so whether this is a square or rhombus, it doesn't matter. Is KM perpendicular to JL? KM, yes, it is. Yes, it is. Okay. All right, let's think about these other ones real quick. So KM parallel to JL? No. Nope. JM parallel to LM? Nope. They definitely run into each other. And then is JL perpendicular to LM? Perpendicular means 90. Is that a 90-degree angle? No, and it'd be basically impossible for it to be, well, I guess if it was, yeah, but it's definitely not here. Okay. Now, be careful on your quiz because there's going to be a question very similar to this on there. This one is multiple choice. I mean, A was the right choice here. But on your quiz, the one that looks like this is actually true, false. And so you're going to write true or false on each one of the statements, not just which one you think is right, okay? So pay attention for that. All right, on this last one, QRST is a square. Find W if QR is that and RS is that. So QR and RS. So in a square, what do I know about those two sides?
90 degrees.
They're congruent. Why?
Because it's a square. It's like a regular square.
Because it's a rhombus. There you go. A square is a rhombus, and rhombus, all four sides are congruent. So we're just going to set that equal, solve for W. So we have 5W plus 4 equals 2 times 4W minus 7. All right, and then just solving. So come on. We get 5W plus 4. What do I get on that right-hand side?
8W minus 14.
Okay, when I distribute, get 8W minus 14. Whoops. Sorry. Okay, then what do we do? Okay, minus 5W from both sides. So we get 4 equals 3W minus 14.
Plus 14. 6.
So W equals 6. Okay, so today we are going to be talking about our last type of quadrilaterals. We're going to be talking about trapezoids and kites. Yes, trapezoids and kites. So, this will be the end of this quadrilateral stuff. Tomorrow we're basically going to do a review where we just kind of overview all of these quadrilaterals, do a little bit of reviewing tomorrow. On Monday, this is my plan for now. On Monday, we're going to do the review for our test on this stuff. And then Tuesday, taking our exam over all this stuff we've been doing for the last couple weeks, 2.5 weeks, something like that. Okay, so a trapezoid. What is a trapezoid? Okay, it's a quadrilateral with exactly one pair of parallel sides. So, is a trapezoid a parallelogram? No, because a parallelogram has two pair of parallel sides. A trapezoid has only one, okay? So, as you look at this, you can see these two sides are the sides that are parallel to each other. And the two sides that are parallel to each other we call the bases. Okay? So on a trapezoid, you're going to have two sides that are not parallel to each other. What do we call those sides? We call them legs, okay? All right, so what I want you to do out here kind of in the margin is I want you to draw a trapezoid and try to draw it kind of big and draw it as symmetric as you can. Okay? Try to be as symmetric as you can. Be as symmetric with it as possible. Mine looks like trash, but you'll get the idea. Okay, so let's put some numbers on here. Let's say this side is 8 feet, this side is 8 feet, this side is 13 feet, and let's say this is 19 feet. Okay, the way I intended for this to be is these two sides are the sides that are parallel to each other. So those are the bases. Now the other two sides that are not parallel to each other are the legs. Now on here, the way we did this is we made those two legs equal to each other. But on a trapezoid, they do not have to be equal. Okay? They don't have to be equal at all. But if they are equal, like they are here, we call this an isosceles trapezoid. So this is more than just a trapezoid. This is an isosceles trapezoid, like an isosceles triangle. What does isosceles triangle mean?
Two same sides.
It's where you have two sides that are the same and the third one is different. Okay? So isosceles trapezoid is the same idea. Basically, it's like you just cut the top off of an isosceles triangle, okay, where this and this are congruent to each other. All right, now, in an isosceles trapezoid, this angle right here and this angle right here, like in an isosceles triangle, what do you think is true about these two angles? Those two are congruent to each other. Okay, those two angles are going to be congruent to each other. And also, okay, so the two bases, the top and the bottom here, 13 and 19, are parallel to each other. So what's going to be true of these two angles right here? Yes, they are going to be supplementary. They're going to add up to 180. Because basically those two angles, well, not basically, they are. Those are same side interior angles. And same side interior angles of parallel lines are supplementary. Okay. So there's a lot going on this page. I'm not going to go through all of this. I just want to hit a couple things because there's really not a lot to say about it. But so let's look at number 1. It says, find the measurement of angle Z. So we're looking for this angle right here. This is an isosceles trapezoid. So what do I know about these two angles right here first? They're congruent. So how big is angle W? It's 82. And then what do I know about these two angles right here? They're supplementary. They add up to 180. So how big is angle Z? It's what?
98.
It's 98 degrees. Yep. Got it. Okay. I'm going to skip down to number 5. Okay, it should have been marked on here, it just got missed, but we're going to say that this is an isosceles trapezoid. And I'm rushing, so I'm forgetting stuff here, sorry, but one thing I want you to know is that in an isosceles trapezoid, the diagonals are congruent to each other. If a trapezoid is isosceles, or a trapezoid is isosceles if and only if its diagonals are congruent. Okay. So going back to this, it says AC is that and BD is that. So that's exactly what this is talking about. If it's an isosceles trapezoid, like what I want us to assume here, then those two diagonals are congruent to each other. AC and BD are congruent. So to find the value of Z, we're just going to set them equal, solve for Z. So we're going to have 2Z plus 9 equals 4Z minus 3. All right, I'm just going to fly through this. So subtract 2Z, 9 equals 2Z minus 3, add 3. 12 equals 2Z divided by 2. And so Z equals 6. Okay? All right, down here on number 6, it says find n to make the trapezoid isosceles. So these two would have to be equal. So you just set those two equal to each other and solve for n. Okay, I'm not going to work through that, but that's how you do that. So pretty simple. Okay, let's go ahead and flip it over. Let's talk about the mid-segment of a trapezoid. So the mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs. So you find the midpoint of each leg, and then you connect those two and you make the mid-segment. So like let's look at number 8 right here. So this right here is the mid-segment of that trapezoid. Because you've connected the midpoint here and the midpoint here, making that one. Now, what this is talking about is the length of that mid-segment is going to be basically the average of the two sides, okay? Or it's going to be the number exactly halfway between there. So let's think about this. This side is 16, this side is 26. The mid-segment is going to be the length that's exactly halfway between those two. What number is exactly halfway between 16 and 26?
20,
What's exactly halfway between 16 and 26?
21. Yeah, it is 21.
What's exactly halfway between 16 and 26?
21.5. I don't know.
I mean, I've heard the right answer. I just want people to think about it.
Let's just keep on guessing.
Because yep. What's halfway between 16 and 26? Okay, and the answer is 21, okay? If you think about it like this, how far is it from 16 to 26?
10.
It's 10 units, okay? And I want to know what's halfway between there, so what's half of 10? 5, and so if you add 5 to 16, what do you get? 21. If you take 5 away from 26, what do you get? 21, okay? So the easy way to do that is just to average them. Just do 16 plus 26 divided by 2, and that'll give you the same thing. It'll be 21. Okay? All right, so on number 9, this time we know the mid segment, and we're looking for PQ. So, I mean, there's a lot of ways to do it. I'm going to do it like this. So how far is it from there to there? To get from 5.5 to 7.5, what do you have to do? Add 2. And so to get here, you're going to have to add the same thing. So how long is PQ? 9.5. Okay? All right. So the last thing I want to talk about here is a kite. All right? So somebody tell me what a kite is.
Is it the you fly in the air on a windy day?
Yes, it is. So tell me what a kite is based off of what this says right here.
Exactly 2.
Okay, so it's a quadrilateral with exactly 2 pair of congruent consecutive sides. So what that means is this, is you're going to have this side and this side. That means consecutive next to each other where these two are congruent. And then you're going to have this and this side that are congruent to each other. And the first set of sides is not congruent to the second set. Okay? So that's what a kite is. I mean, that's an actual shape, is a kite. And you can see where the kite that you fly in the sky, where that comes from. It's from this shape right here. Okay, now that's the definition of a kite, is exactly 2 pair of congruent consecutive sides. There's 2 properties that we're going to look at here. The first one is that the diagonals are perpendicular, just like in a rhombus. Okay, so where the 2 diagonals meet, it's going to make a 90-degree angle. The other property is that exactly 1 pair of opposite angles is congruent. So like this angle G and this angle J are going to be congruent to each other. F and H will not be congruent to each other within this definition of a kite. Okay? So we're going to use those 2 facts to help us answer these questions. So on this one, it says in a kite ABCD, angle BCD is 98. So BCD is this whole angle right here. So this whole angle is 98 degrees. And then the other thing it tells us is that angle ADE is 47. And so ADE is this angle right here. That one's 47. Okay, so that's all they give to us. Now we've got to find these 3 angles. So the first one is angle DAE. So DAE is this angle right here. Okay. Now there's one of the properties that I'm going to use right here to help me find that angle DAE. What do you think I'm going to use here to help me with that? The diagonals are perpendicular, so what's that going to tell me? That angle DEA is 90 degrees, right? And then if you just think about this triangle right here, okay, the 3 angles of that triangle add up to what?
180.
180. So I'm going to do 180 minus 90 minus 47. Okay, and that gives me 43 degrees. Okay, so that's the answer to that one. 43 degrees. Okay, next is angle BCE. So BCE is actually this right here. Oh, no, it's not. Sorry, my bad. Totally, sorry. BCE is this angle right here, my bad. Okay, most people think, they just say, well, it's half of 98. No, it's not, okay? Because that diagonal CA does not cut that big angle there exactly in half. But this is symmetric, right? It's symmetric across. So since this angle is 43 right here, this angle right up here is going to be 43. Because the other property said like the opposite angles, 1 pair of opposite angles is going to be congruent. So these 2 would be congruent to each other. So that makes this one and this one equal. So this angle right here is 43. So how am I going to find this angle right here now? Yeah, I'm just going to take the total of 98, take off that 43, and what does that leave? It leaves 55. Okay, so this is 55 degrees. Now the last one there, it's asking for angle ABC, which is this angle right here. Okay, now if you think about this, all right, just think about this triangle right here. Okay. So this is an isosceles triangle. That's exactly right. And so just like on the other thing, if that angle is 55, this angle is 55. How am I going to find that angle up top that I'm looking for? Yep, they add up to 180. So 55 and 55 makes 110. So what else do I need to get to 180?
70.
Is 70 degrees. That's the answer.